Hey everybody, Morgan here. So what we're talking about today is introducing a new topic for honors chemistry, and it is an idea called the mole. Okay? Now, there are a lot of different ways that we can talk about what a mole is, but we're going to start off by calling it a counting number. Okay? Now, there are other accounting numbers out there that you are familiar with, like a dozen. A dozen means 12. A gross means 144. A score means 20. So regardless of what it is we're talking about, if I say I have a dozen of those objects, I have 12. A dozen eggs is 12 eggs, and a dozen Cadillacs is 12 Cadillacs. Now, a dozen eggs is pretty small, and a dozen Cadillacs is pretty large, but there's still just 12 of them. Same thing with a gross or with a score. Now, a mole is made up of Avogadro's number, 6.022 times 10 to the 23rd pieces of whatever it is we're talking about. If I have a mole of water molecules, I have 6.022 times 10 to the 23rd water molecules. If I have a mole of Cadillacs, I have 6.022 times 10 to the 23rd Cadillacs. That's not actually possible, but you get the idea. Now, the name mole dates back to a guy named Avogadro. And he developed this idea using gas laws. And if you had a mole of a substance, you had a relatively big pile of it, not unlike those big piles of dirt that are left behind when you have a mole digging out in the yard, or that pile of dead skin cells, which might be on the back of your hand, and we refer to that as a mole. Okay, now, this number is large. It's a really big number, okay? If we actually had an entire mole of peas, it would cover an area the size of the United States to a depth of 6 feet. Okay, so that tells you it's really a huge number. Now, to count a mole of pennies takes some time. Imagine that you're counting out pennies at 100 pennies per minute, and you're doing it 12 hours a day, uninterrupted, 365 days a year. And you get everyone else on planet Earth to help you, okay, which is about 6 billion people. It's still going to take you 100,000 years to count out that many pennies. So that's a lot of pennies, okay? Huge number. Now, the number itself is not made up. It's actually based on something. The isotope carbon-12. We assume it weighs 12.000 grams. And it's how many carbon atoms are in 12.000 grams of carbon-12. Okay? I'm old enough that I saw some books when I was in school that referenced it being based on oxygen-16, and then they changed that. And we had to adjust the masses on the periodic table to a certain extent. Okay, now, why are we going to use moles in chemistry? Well, there's a few different reasons. One, atoms are too small for us just to work with an atom. We work with a ton of them, and then we need to weigh them rather than count them. Okay, so that is part of it. But our balanced equations from the last chapter, let's rewrite that. Let's go 2H2 plus O2, both of those as gases, to give me 2H2O gas. This actually represents a mole ratio. We talked about it being 2 molecules of hydrogen to 1 molecule of oxygen. Well, it's also 2 moles of hydrogen to 1 mole of oxygen. Okay? So another thing that does provide a little confusion in this, just to give you a little background here, is we always try to talk about the smallest piece of something that we're dealing with. And I try now to use the term particles. Okay? Now, particles could mean molecules. It could mean atoms. Okay? We could be talking about even ions. All right? So, Avogadro's number would hold for all of these. So, the smallest particle of water is a molecule. So a mole of water has 6.022 times 10 to the 23rd molecules. But the smallest particle of gold is an atom. So if I have a mole of gold, it's 6.022 times 10 to the 23rd gold atoms. So you get the idea there. All right. Now, molar mass. Molar mass is going to be a major theme for this. Okay? And some people call it formula mass. Okay, some people might even refer to atomic mass. It's all the same idea, but the unit changes. If we're talking about the mass of a single molecule, we do it in atomic mass units. If we're talking about a whole mole of it, we do it in grams. Okay? So, how do we calculate molar mass? What is molar mass? Okay, first off, it's going to sound sarcastic, but we use a periodic table when we're doing this. We calculate molar mass by using a periodic table. What is the molar mass? It is the mass in moles of, the mass in grams of 1 mole of a substance. Okay, so the words seem strange, maybe, but the actual doing of this is quite straightforward. Water has hydrogen and it has oxygen. There are 2 hydrogens and there's 1 oxygen. And now I bring in the periodic table. The mass for hydrogen is 1.01, we'll round it off. And the mass for oxygen is 16.00. So 2 times 1.01 and 1 times 16.00. And when we add that up, we get 18.02. And our units will be grams per mole.